Detailed considerations for monitoring and controlling downhole pressure. Monitoring and controlling downhole pressure involves several critical considerations related to operations, maintenance, and control. Here are detailed explanations with specific practical examples of potential issues and strategies to overcome them. Operations. 1. Instrumentation selection. Accuracy and precision. Instruments with high accuracy and precision are crucial for detecting small pressure changes. Range. Ensure instruments can handle the expected pressure range, including transient pressures during drilling, completion, and production. Durability. Instruments must withstand harsh downhole conditions, including high pressures, temperatures, and corrosive environments. Example issue 1. Instrument failure due to high temperature and pressure. Problem. Standard pressure gauges failing at high temperatures and pressures. Solution. Use quartz pressure gauges designed for high temperature and high pressure environments. These gauges provide reliable performance and accurate measurements under extreme conditions. 2. Real-time data acquisition, data transmission. Implement reliable data transmission systems to relay real-time pressure data to the surface. Power supply. Ensure continuous power supply for downhole instruments, potentially using battery packs or downhole power generation systems. Example issue 2. Data transmission interruption. Problem. Interruption in data transmission due to cable damage or signal interference. Solution. Use high-quality, robust cables with protective sheathing and redundancy in data transmission paths. Employ wireless telemetry systems where feasible to avoid cable issues. 1. Scheduled maintenance. Calibration. Regularly calibrate downhole pressure instruments to maintain accuracy. Inspection. Conduct periodic inspections of downhole equipment to detect and address wear and tear. Example issue 3. Calibration drift. Problem. Pressure sensors drifting out of calibration over time. Solution. Implement a routine calibration schedule and use calibration devices capable of being deployed downhole to recalibrate instruments in situ. 2. Replacement and upgrades. Modular design. Use modular instrument designs that allow for easy replacement and upgrades without extensive downtime. Material upgrades. Upgrade to materials that better resist downhole conditions, such as improved corrosion-resistant alloys. Example issue 4. Corrosion of downhole instruments. Problem. Corrosion of pressure sensors leading to inaccurate readings and potential failure. Solution. Replace sensors with models made from high-grade corrosion-resistant materials like Inconel or Hastalloy. Implement chemical treatment programs to reduce corrosive elements in the well. Control aspects. 1. Automated control systems. Integration. Integrate downhole pressure data with automated control systems to adjust well parameters in real time. Algorithms. Use advanced control algorithms to predict and respond to pressure changes promptly. Example issue 5. Overpressure events during production. Problem. Overpressure events leading to equipment damage and safety risks. Solution. Implement automated control systems that can quickly adjust choke valves or alter flow rates to maintain safe pressure levels. Use predictive analytics to anticipate pressure surges and take preemptive actions. 2. Redundancy and safety systems. Fail-safes. Design systems with fail-safes that activate in the event of a sensor failure or data loss. Emergency shutdown systems, ESD. Integrate ESD systems that can automatically shut down operations if dangerous pressure levels are detected. Example issue 6. Sensor failure during critical operations. Problem. Failure of a critical pressure sensor during operations, leading to loss of monitoring capability. Solution. Implement redundant sensors at critical points to ensure continuous monitoring. Configure the control system to default to safe operational parameters if a sensor fails, and trigger alarms for immediate investigation and remediation. Practical examples of issues and solutions. 1. Issue. Instrument failure due to high temperature and pressure. Problem. Standard pressure gauges fail at high temperatures and pressures. Solution. Use quartz pressure gauges that are specifically designed for high temperature and high pressure environments, providing reliable performance and accurate measurements under extreme conditions. 2. Issue. Data transmission interruption. Problem: interruption in data transmission due to cable damage or signal interference. Solution: use high-quality, robust cables with protective sheathing and redundancy in data transmission paths. Employ wireless telemetry systems where feasible to avoid cable issues. 3. Issue: calibration drift. Problem: pressure sensors drifting out of calibration over time. Solution: implement a routine calibration schedule and use calibration devices capable of being deployed downhole to recalibrate instruments in situ. 4. Issue: corrosion of downhole instruments. Problem: corrosion of pressure sensors leading to inaccurate readings and potential failure. Solution: replace sensors with models made from high-grade corrosion-resistant materials like Inconel or Hastalloy. Implement chemical treatment programs to reduce corrosive elements in the well. 5. Issue: overpressure events during production. Problem: overpressure events leading to equipment damage and safety risks. Solution: implement automated control systems that can quickly adjust choke valves or alter flow rates to maintain safe pressure levels. Use predictive analytics to anticipate pressure surges and take preemptive actions. By addressing these considerations and implementing the suggested solutions, oil well operations can achieve more reliable and accurate downhole pressure monitoring and control, enhancing overall safety and efficiency.